This video is mainly going to go through definitions as we define the terms that are going to be necessary for Unit 5 that deals with transformations. Some basic geometry definitions, including a point, a line, a ray, a line segment, angles, things like that, will be where we begin, and then we'll move into a few others as well. A point is something that has no dimension, and it just is somewhere. It's an exact position or location. If we are referring to a specific point, this is how it's usually labeled. Okay, that would just be point A. If we are referring to a line, in order to define the line, we have to have 2 points that are on the line, and a line extends infinitely in either direction, which means it has no beginning or end. If I am describing this line right here, I would use points A and B to name the line, and then I put a line over top with arrows in either direction. Sometimes lines might be labeled L, like line L. It might be labeled other than that, but that's not actually defining the line. That's just a name for the line. We can also find the linear distance between 2 points on a line, and we're going to talk about that more actually in a later unit. But if I'm looking for the distance along the line, this is how it would be notated. A ray is similar to a line, except that it actually has a definite beginning, and then it extends infinitely in one direction rather than in both directions. Again, I do need 2 points to define a ray. This time when I write it, I use a ray above it, so the arrow only goes in one direction, not in both. And it does matter that I put A first and then B, because A is where it starts and then it extends infinitely beyond B, just like my ray does here. A line segment, also defined by 2 points, but now those 2 points are endpoints. So the line does not extend infinitely. It has a definite beginning and end. And this time when I write it, I would put that over top, just a line segment, no arrows. And I know it's nitpicky, if I were to count, if you were this was supposed to be for a ray and you put as a line segment, but we have to be specific, otherwise we could be talking about totally different things. An angle is formed when 2 line segments or rays share an endpoint. It could also be a line that shares that endpoint, like this one down here. But notice that these go in different directions and they form an angle right here. If I have an angle that looks like this, whether it's acute or obtuse, it doesn't matter. If this were the case, then I could say, okay, that's angle A. And there's no confusion as to what angle A is. However, in this situation over here, if I just say angle A, I could be talking about this angle here, or I could be talking about this angle here, because both have a vertex of A. And the vertex is right here, that point that they share. So in this case, in order to specify which angle I'm talking about, I need to use all 3 letters when naming it. And in this case, I could name it angle BAC or angle CAB. Either one is fine, as long as that vertex is that middle letter. Either way is fine. Definition of an acute angle: less than 90 but greater than 0. Obtuse, greater than 90 but less than 0. So acute, this would be an example of acute. Obtuse would be something like that, greater than 90 degrees. And then a right angle, exactly 90. When we define some of our transformations, knowing what parallel and perpendicular lines are is going to be helpful. Parallel lines excuse me, never cross. We probably already know that. And then if I say a line is parallel to itself, obviously I'm talking about one line on top of itself. But as long as they have the same distance in between them, then they are going to be parallel lines. Perpendicular lines meet at a right angle, and so when they meet, they create 4 right angles, because if this is a right angle, then this side also has to be a right angle, because together these form a straight angle, and 90 and 90 gives me that straight angle of 180. So if this one's 90, then this one also has to be 90. Same is true for here, and then the same is true for there. Circle. The circle is a set of all points that are equidistant from the center. What I mean by that is, if this is my center, and let's see, I create a radius out to the edge of my circle, then as I sweep this radius around to draw my circle, that circle, that's a horrible circle, but all of the points on that circle are going to be the same distance from the center. When we draw any 2 radii of a circle, we're going to create an angle. And one thing to note is down here it talks about an arc and arc length. When I create that angle, I also have arcs here. And if I have, if I'm talking about angles, here it says angle AOC, which is this larger angle here, is greater than angle AOB. So obviously this whole angle is larger than this smaller angle here. And I can see that this arc is also larger than this smaller arc here. So if the larger the angle, the larger the corresponding arc. Same thing is true with segments. OA is longer than OX, so this arc is longer than this arc. It talks about it down here. Alright, so let's talk about a couple of examples before we finish up. It says, can a line segment be defined using the points A and B? And yes, it can be. Remember that it has to be defined using 2 points. So if I were to name this, I would name that line segment AB. Can it be defined just using point C? No, it has to be defined with 2 points. So if I had another point on here like CD, then I could define that. But the way it is right now, I cannot. In this first figure, do these 2 segments form an angle? Yes, they do, because I have 2 line segments and they share a common endpoint of B. In the second figure, they don't form an angle because they don't share a common endpoint. We have line segment AB and CD. If it extended and shared this endpoint, then yes, but since it doesn't, it does not form an angle. If I look at this, it tells me that by definition they are perpendicular. AB is perpendicular to CD, and we could also state that this way. AB, line segment AB, is perpendicular. It's a symbol for perpendicular and upside down, capital T. So AB is perpendicular to CD. You could say it that way as well. because this is a right angle. So I can kind of go back and forth. I can either be told it's perpendicular and then know that this is a right angle, or I can be told that this is a right angle and then know that they're perpendicular. But remember that if they are perpendicular, then they form 4 right angles, so all of these are right angles. So when it asks me for the measure of angle AXC, angle AXD, and angle DXB, all of them have a measure of 90 degrees. I'm given this information. It says are AB and CD parallel. So let's look at this information and determine if they're parallel. It tells me that AB and AC are perpendicular, and that AB and BD are perpendicular. And it also tells me that AC, that this line segment, is congruent to this line segment. So I have the same distance between them. And that means they're also going to keep the same distance. So these would be parallel. If they are the same distance between them, that means they're never going to cross. So these would be parallel. Looking at this, it looks like they're not parallel, but in geometry I can't just look at the diagram. I have to look at the information that I'm given and determine it from there, rather than just by assuming from the diagram. So when I look at this diagram, I have WY is less than XZ. So if this is less than, if this distance is less than this distance, then eventually, it's horrible, but eventually those are going to cross. They're not going to stay the same distance apart the whole time, like the previous. So these two are not parallel. Alright, lastly, when we talk about circles, remember that in a circle, all radii are the same length. So if I draw from the center of the circle to the outside, center of the circle to the outside, these are going to be the same length, and those tick marks right there just are showing that they're congruent. So those are going to be the same length. If I were to draw another one, it would be the same length no matter where I draw a radius. All radii are going to be the same length. So if I know that AB and BC are congruent, that's what it says up here, it asks, is the set of points with center B a circle? So is this a circle right here? Yes, it will be, as long as each of these radii are congruent. If I look at this, again, it may look not circular, but I have to look at the information given, not just assume from the diagram. So when I look at this, it says that XY is greater than YZ. So this would not be a circle, because in order for it to be a circle, the radii have to be the same length, and they're not the same length. This information is going to help us as we move into our different transformations in the future.